Welcome to my TED Talk. That's my daughter told me to say that. Obviously, it's not a TED Talk. So I'm going to just give a very kind of brief whiz through an approach to data warehousing that I kind of dreamed up recently. But before that, a little bit about myself. That is my Deloitte corporate photograph. I no longer work for Deloitte. I finished with them last week. I'm now working on a privateer. On another project, which is very exciting. This is more like real life. This is me trying to get work done in my normal working day with animals about me trying to interfere with what I'm trying to do. So I am British by birth, but for the past 14 years, I'm a resident and citizen of Australia for the weather, apparently, even though the floods would say otherwise at the moment. I started my career way back in 1989 as a trainee COBOL programmer on IBM mainframes. It's interesting that a lot of stuff I learned back then is still applicable today. So the world hasn't changed as much as we think it has. I learned about data modeling in the early 90s when my boss at the time was a very enlightened guy, no longer with us, unfortunately. Introduced it to our team, and it really did change my life in terms of the way that I approached pretty much every IT project I've ever worked on ever since. I've got a fair bit of database development experience, SQL Server, Oracle, and more recently, cloud technologies. Analytics, data analytics, the past 10 years, I guess, specializing. Before that, just generally database design stuff and development work. I am a certified Data Vault 2 practitioner. I'm assuming most of the people on this call are Data Vault-y type people. So we are, I hope I'm amongst friends, because a lot of what I'm going to say today may challenge the status quo. Yeah, so please keep an open mind. I'm not coming after your jobs. I'm just interested in starting a discussion. I have dabbled in a bit of coding in C# and Python. And I consider myself to be a kind of technology skeptic. So I think we get kind of distracted with, the new shiny toys. And I'm a firm believer that we need to kind of base our work in sound engineering practices. And those don't really change much over time. So, yeah. So I kind of very scornful of new technologies when it's just kind of repackaging of what we've seen before. Okay, bit of housekeeping. Please put yourself on mute. I think everybody has, so that's great. Please save questions till the end because I'm easily distracted. I do not multitask well, so I don't want to trip over myself. And we've got a fair bit to cover, so I will try and keep on track. I'm going to try and get through in about 45 minutes, but there's a bit in here if I start waffling, which I've already started doing. Thanks to Christian for inviting me. Very honoured and flattered to be invited, and also the people on folk at Ellie and Idera for giving me access to the tools. So a lot of the diagrams in this deck I've produced using Ellie and the Idera ER Studio data modeling tools. So first question, why do we need another methodology? Depending on which reports you read and your definition of success or failure, between 70 and 80% of data warehousing programs fail. So I believe. So I'm led to believe. Why is that? Well, in my view, there's a disparity between the way the business views data and the way technology views data. Business is very kind of messy and fuzzy and difficult to pin down. Technology is kind of very, I guess, binary, and meeting in the middle is difficult. So I got to thinking that we perhaps need a way to bridge that gap between that kind of messy business world and the technology view. So that's kind of the underpinning principle of what Hook is all about. Now, before I go into describing Hook, I want to talk a little about what I would call logical architecture. And before I do that, I just want to revisit this question: is what is a data warehouse? And this is going to be not new to any of you, I hope. And I'm going to trot out the definition. The data warehouse is a subject-oriented, integrated, time-variant, non-volatile collection of data in support of management's decision-making process. The famous quote or a definition by Bill Inman. So there's 4 criteria in there. So we need to align to the business terminology, subject-oriented. We need it to be integrated. So in a sense, I visualize this like a library. So you want to go into a library and say, right, where's all my information on science? And you know where to go in that library. So it's the same really for our data warehouse. We want to be able to know where to go to find information about customer or product or whatever. Time variant, we need to keep a historical record. And non-volatile, which is really important one that I think people don't give enough attention to, in that once we've written data to the warehouse, we do it once and we never update it. So if we do need to make changes, we write new versions to the data warehouse. So that's really important, that is a criteria of what a data warehouse is. So I don't know, can we start using this terminology? Can we start calling these the Inman criteria? Because I think that would be really useful. Rather than have to trot out those 4 definitions, just say those are the Inman criteria. And what Hook is about goes to the heart of those 4 criteria. It's the data warehousing component that we're interested in, not the whole data platform. Okay. This is a diagram I scraped off the internet. It's just a typical architecture diagram. To me, this is not logical architecture. This is a physical architecture. It is littered with lots and lots of bits of technology. That's not what I'm talking about here at all. What I'm talking about in logical architecture is what are the main functional pieces of a typical data platform. Okay. So in my view, there are 6 components. You have your source data. So these are your operational systems which you use to run your business and from which we extract data. We have landing. So this is the area where we extract information from the sources and keep that information ready to load. But it's more than that. It's not just those tables. It's also the mechanisms that we use to extract that information. So we're only loading new data. So this is our change data capture type stuff. So that's what I mean by landing. It's not just the storage, it's also the processing that we're talking about. Ultimately, we want to get to a point where we're integrating that data, as I mentioned before on the previous slide. But the shape of the data and integration will be different to what it is in landing. The data in landing is very much aligned to source. Our integration layer will be organized around some kind of methodology or modeling paradigm. So it might be data vault, or it might be a Kimball type structure. The point being is that the structure in landing is different to the structure in integration. So our staging is that kind of switch point where we do that conversion. So there'll be standard patterns where we go from source aligned to business aligned. And that's kind of where we're aiming for. At the back of the integration, we have a business logic. So this isn't storage. This is all our ETL, and these are all our AI and machine learning routines and KPI calculations. And anytime we apply any business logic or business rules, that's what we just bundle it all, and it's all in business logic. So that has an input of information from our integration layer. And then we've got the option then at the output of that logic being run, we can either re-ingest it back into the warehouse, or, sorry, got an echo there. So we can either re-ingest it back into the warehouse, or we can push it through to what I would term a consumption layer. So this is where we've designed specific structures for querying the data. So it might be a star schema or flat files or whatever it happens to be, whatever we want to consume. The point being that the consumption layer is entirely a throwaway. We could delete everything out of the consumption layer, confident that we can rebuild it completely with what we have in the integration layer and that business logic. So that's kind of a general purpose, very simple view, left to right view of your typical data platform. So if we then go back to our Inman criteria and ask which of these layers actually correspond to our data warehouse, then it's just that one. It's that integration layer. Nothing else really hits those criteria. So this is what I said before. Hook looks at this bit. This is the integration layer, not all this other stuff that goes around the outside. So saying that, Hook has a slightly different view of that architecture. So here we have sources, the same, landing, and we have our staging. But our staging isn't the staging in the sense that I described before. Staging here is a persistent staging area, or another word for that is a data lake. And then our integration layer essentially encapsulates that storage. Okay, so this is all source aligned. This data lake is all source aligned, but our integration layer needs to be business aligned. So the way we achieve that is we have some metadata. and a series of views that we can sit over the top of those data lake tables to align it to the business concepts. Okay. And then everything else downstream is exactly the same. There's no difference at all. Okay. Hopefully that makes sense. So you've got the same boxes, they're just kind of organized slightly differently. And in this case, the data warehouse then incorporates that data lake structure as well. Okay, hook components. So before I get into this, I'll just kind of give you a background as to why I kind of tried to dream up a new methodology. I don't know if anybody who's kind of shares this kind of story, but it seems to happen to me kind of frequently, where as a consultant, you arrive at a client and who have already decided that they want to deploy a data vault methodology into their data warehouse. Okay, so that's a given. We haven't had a discussion. They just say, we want data vault. The deliverables, budget, timelines, they've already been agreed. Okay, they're locked in. We've got to deliver these reports by 6 months' time. We've got to go now. Okay. But then you ask about the business architecture, and there isn't any. There's no data models. There's no business glossary. There's no concepts at play that we can actually organize that data vault structure around. So you ask about that and say, well, can we do that? And they say, well, no, we don't have time. We don't have the funding. To be honest with you, we don't have the motivation to do any of that stuff. And data vault was sold to us on the proviso that it's agile and we could just do it and then fix it all up in the business vault. Okay, and I think we kind of know that's not always the best approach. So in my view, we're kind of off to a really bad start. We're not really heading in the right direction. We're kind of fumbling around. So I thought, well, given that those are the conditions that we're heading into this, what do we do about it? Wouldn't it be good if we had a methodology or an approach that didn't need us to have that business architecture in place before we started? What if we had an approach that enabled us to change that business architecture, change our models without having massive impact on our data warehouse? So we can actually change very easily without having to do massive amounts of re-engineering work. Yeah. And what if we could do that in such a way that we didn't even need to reload any of our data? So once we've loaded it, we've done it once and that's it. And then we can change the organization structure virtually after the event. So that's what Hook is aiming for. So if we want to visualize what's going on, you've probably seen this diagram because it's on the Meetup page. So I'll go through the components of what Hook is. So the main underlying principle is business terms. So it's all around the business glossary. It's really important that we have a set of business terms defined in our business glossary. In Hook, we call them hooks. It's really imaginative branding, but that's what they're called. And if you want to visualize them, they very much like Hook. So we'll have a hook which represents customer. We'll have a hook that represents order. We'll have a hook that represents product or whatever. These are things in our business glossary, and we can physicalize them as things in our hook schema. Then we have our data lake tables. So this is our source aligned data that we've loaded from our source systems. And then what we do is we wrap that data lake table in a bag. I've called it a bag. It just seemed like you put something in a bag, kind of makes sense. And you can then hang that bag using our hook keys, and I'll show you this in a second, from those hooks. So this is all source aligned. This is our business aligned stuff, and our hook keys give us that transition between the two. So you kind of got these bags give you both views, both the source aligned and the business aligned view of the world. And those of you familiar with data vault go, well, this is all exactly the same. And I'll be honest, I've borrowed and stolen ideas from any methodology I can, specific and especially data vault. The final key component is key sets, and these are, and I hope we have time to go over these, is where we qualify. We use key sets to qualify business keys within the methodology. So those of you familiar with data vault, this is exactly the same principle as a BKCC, business key collision code. It's exactly the same concept, but it's kind of a first-class citizen within this methodology. It's really, really important part of the methodology. Okay. So we dive into the glossary. So say this is a fundamental component of the methodology. We need business terms and they're mandatory. So if we want to organize our data around any kind of business concept, we have to define the term within the business glossary. Okay. Now, this is an interesting one. We want to keep that list relatively manageable. It's very easy to just keep defining terms, and you know, it's like in Data Vault, you can just go create a hub, and you end up with hundreds and hundreds of hubs. I'm suggesting here that we need to keep that number to a manageable level. I did a bit of research around this and discovered this thing called Dunbar's number, and this is Dunbar's number is the it's a measure of the number of relationships, personal relationships, a typical human being can have. So in your kind of social network, it's family, friends, that kind of thing. It's that number that you can comfortably manage, that number of relationships. And I thought, well, this kind of makes sense. So 150 sounds like a good number. I was looking for something between, say, 100 and 200, but it seemed like a good number. So if you had that and you looked at your all 150, you get a sense of what your business was about. So that's really all we're looking for there. We're not looking for really fine detail here. We want to have broad understanding of what's going on. Of course, it needs to be 100% business focused, absolutely essential. That's what it's all about. And our business terms have certain criteria that we need to meet. So they need definitions, clear, concise, and correct. And we all know how easy that is to do. That's a challenge, but it's really important that we have that. Examples of those terms. So when we've got a definition, we want to be able to give a, so customer, well, what types of customer do we have? And list those down, give some description around them, but they must match the definition that we've given. Ideally, we need to assign a data steward, somebody within the business who has a responsibility for this stuff as well. So somebody we can go to and say, hang on, is this right? And question them. And if they don't know, they can go and find out. Optionally, we need things like synonyms. So you say customer and client, are they the same thing? One of those terms will be a core element or a core term. The other one would be a synonym. So just to keep track of those. Rules, business rules, so we can get a sense of ontology. Customers buy products, customers raise orders. Those are simple relationships that we can record. Taxonomies, classification structures, that kind of stuff. All useful information to help give us a better picture and better description around those business terms. And in Hook, typically, one hook is one business term, but also we can have combinations of business terms for one hook. So you can kind of think of a composite hook with multiple business terms, a bit like a link in Data Vault. On the other side, the enterprise conceptual model. So we need to do some modeling, don't we? Well, no, you don't. It's not essential in the hook method. What's important is those business terms. Now, if we choose to then arrange them into models, then we can. But because it's a separate concern to the data that we've ingested, we don't have to enforce the structure of the model on our data warehouse. So we're separating concerns of modeling and loading of data. We can use those models to help us understand business ontology, which we've discussed here. Also for taxonomy. So essentially there's a kind of a symbiotic relationship between business terms and models. The work we do over here can only improve the quality over here, and what we get out of this side, we can then plug into our conceptual models. So yeah, you don't have to do modeling, but it's probably a good idea if you do. Right, probably for you guys, the interesting stuff, we get into what the bags actually look like. So I've kind of given an example here. So say we landed some data. It's an order table that we landed from our source system. So it's got order number, reference, client ID. We've got a whole bunch of fields in here. When we load that into our data lake, we copy it in field for field, no transformations. We don't do anything with it. We just copy the data in exactly as is. All we'll do is we'll add some audit columns. When we loaded it, which source system it came from, and whatever your standards require, whether you've got a batch, load, process ID or something like that in it, doesn't matter. Then over the top of that data lake table, we place a bag view, okay? And again, we're not doing any transformations here. We're just copying through each field, one for one, into that bag. And it's a view. So it's a virtual thing. It's not a physical, it isn't a physical table. It can be, but doesn't have to be. And it's just field for field. Then what we do, we need to align that to our business concepts. And we do that by projecting out a bunch of fields, which are our hook keys. So here we've got our order number has been projected out into our order hook key. And then we've got customer mapping and two versions of address, a delivery and billing address. Okay. Point is that the naming conventions for these hooks have to align to our business glossary. So you would expect order, customer address to exist in our business glossary. That's a hard rule of the methodology. So if you don't have them in the glossary, you can't do that. Okay, so it kind of forces you to align the data according to your business glossary. So we look at the DDL that we might generate from that. It's really simple. We're just doing a select, basically all the fields from the lake table, and then we do these projections. Yeah. I said it was a view. We could materialize that view if we want performance. We could put in a table if we really want to, but then we'd have a pipeline that we'd have to maintain and build. Again, it's all pattern based, so it should be pretty easy. Again, sorry, let's just pop back. Again, these align to our business glossary, so these terms have to exist in our business glossary. And the idea is that we cast everything to a var binary. The idea there is that we're not doing hashes or we're not doing any of that kind of stuff, but if we turn everything into a var binary, we'll be using much less space, but we'll still get the efficiency of any joins that we perform on them. Okay. I'd still like to see some empirical evidence that a 32-byte hash key is more or less efficient than an 8-byte long var binary field. I suspect that the shorter the key, the faster it would be, regardless of whether it's variable length or fixed length. Those are our key sets. So we need to qualify every single key, business key, with a key set. And we'll talk a bit more about that in a second. And because it's a view, we can do stuff like this. And I haven't really fleshed this out, but we could potentially do our row level filtering on this. So we can, this example is saying here we've got a function access policy which filters users if they're in the finance group, then we'll show them the row. There's lots of stuff we could do to unpack that, but the fact that it's a view means that we've got the option to do that kind of thing dynamically. Okay, right, key sets. Say we built a bag over the top of this particular lake table. So here it is. Now we've kind of looked at that and we realized that we missed something. We've got this order reference field in here that we haven't identified as being a hook, but it is. This also refers to, it identifies an order, as does this order number. So it's perfectly legitimate. So there's no reason at all why we can't pull that out as another hook into the concept of order. So the great thing about this is we can do that. We can just drop that. We drop that bag. We haven't dropped the data because that's all in this table here, and we create a new one. So now what we've got two fields: order number and order reference. So we've had to qualify them to say one refers to the order reference, one refers to the order number. But we've just been able to drop that, reproduce that. We don't have to we have to change any other code. But what we do have to do is create a new key set. So here they've been defined numerically. So 13 is the set of business keys which refer to order number, and 14 is a set of business keys which refer to order reference. So you need to track these, within your metadata, you need to track all of these key sets. So how can we use these? So one use is that we can use it for qualifying sources, very much as the BKCC does in Data Vault. So say we had two systems or two sources of data, Gadgets R Us and Widget World, and they both have business keys in them referring to a product 45. Because they're from different systems, the chance of those being the same product are very, very slim. So we need to qualify those codes with something. So this is why we create our key sets. We've got a key set 65 and a key set 66. One is for Gadgets R Us, one is for Widget World. We qualify those business keys with the ID of the key set, and now we have a unique combination. So there's no risk of accidental passive integration. So it's kind of ensures that we're keeping different business keys separate. So that's one obvious use. Another one is to qualify taxonomies. So say we had a taxonomy like this. We've got vehicles. We've got land vehicles, air vehicles, water vehicles. So this is a hierarchy that I built using Ellie. then we can come up with a whole bunch of key sets for each of these kind of leaf level entities. So 101 to 107, referring to automobiles, human powered, all the way through to sailboats. So they all roll up to this top level business concept. So that would probably be our core business concept. We probably wouldn't bother modeling these out as core business concepts, but we can roll everything up to vehicles. These are all vehicles, okay? So within our bag, we can then do exactly that. We then say, right, well, we're going to name it vehicle, but because we've loaded this one from the sailboats table, then we can prefix the sailboat number that we have from that system with 107, which tells us straight away, if we look up the key sets, that that's in fact a sailboat. So you can use these key sets to, not just to identify systems, but also what type of things we have. And I think there are other uses. There will be other uses for key sets. So that, I think that needs a bit more thought. Okay. Now this is kind of a bit of a architectural summary slide, if you like, just to kind of bring it all together. So basically, starting at the bottom, we have our source tables. This is the data we're bringing in from our source systems. Okay. This is very technology oriented. We take the data as is. We don't mess about with it. We just load it as is. We then load that information into our data lake tables. We add our audit fields, but essentially it's still source aligned. And we can set up a bunch of sprints to perform that activity. So we can have a team set up which says, right, you guys go and grab data from these systems. And there are particular skills. Obviously, there's different ways of grabbing that information. There are CDC mechanisms that we can put into place, and the guys on this team would be expert in that kind of stuff. They don't have to worry about any kind of businessy stuff. They just need to worry about how do we get the data into the lake. At the other end of the spectrum, we've got a whole bunch of modelers going out, speaking to the business, trying to understand how the business works. Getting our glossary together, getting our business terms, and building data models. So just trying to get an understanding of how the enterprise data structures actually hang together. So we have an understanding. And again, that modeling exercise can happen completely independently of what's going on down here. They're two separate exercises. So they can happen independently of one another. And then in the middle is where we put our virtual set of bags in, and this is the point where we take our source aligned information and align it to the business. And because it's virtual, we can blow it away and recreate it, and we don't damage anything that's going on above and below. And that's a special set of activities which I would call an alignment sprint. So this is where we're kind of saying, right, okay, here's a particular data lake table. How are we going to align that to what business concepts do we have, and we can build the bags dynamically from that. Okay. So I've got an example. I'll run through an example. So consider we've got a multinational global company that has two brands. We go back to our Gadgets R Us and Widget World brands, and those may have been separate companies that have their own systems, and we want to bring those together, the data from those into our enterprise data warehouse. So we have the data from those and we load them in, and then we want to organize those around some kind of integration scheme, ideally based off our data model, but around the business concepts. That's what we're interested in. So we're going to have a look at the Gadgets R Us data, and we go, okay, well, here are 4 particular tables from that source system. We've got a client table, we have orders, orders have order lines, and each of those order lines relates to a gadget. So that's the language and terminology that they use within that particular business. So we can simply put this together. We can go, okay, well, we've identified that client, order, and gadget, they sound like they're our core business concepts. So we'll create hooks for those, client, order, and gadget. And then for each of these tables, we will wrap in a bag and we will point them to those particular concepts. So here you've got order line. In that table, we've got a reference to an order number and a gadget code. So therefore, we point that to order and gadget. Really simple stuff. There's nothing clever or fancy about that. Now, in Widget World, they've got a similar model, but it's not quite the same. Okay, they're using different language. They're using shopper, basket, widget. They're not using the same language that we've used in the other area. So when we put that model together, it might look something like this. Again, we've still got 4 tables, and we've got 3 concepts at play, but they've got different names. Okay. The basket, the basket item is referring to all three of these concepts. That's why I've got three relationships, and then each of these relates to one. So that's all fine. From a modeling perspective, from Widget World's perspective, that's great. That works fine. The difficulty is what happens when we try and bring these two together. We've got different terminology. We've got client, order, and gadget here, and we've got shopper, basket, and widget here. They're different names, but they're probably similar things. So if we want to bring these two models together, what do we do? Well, it's really simple. So in our glossary, we conform the terms. We go, well, client and shopper, well, we want a common term that we want to use for those. So we'll go with customer. It makes sense. So this is purely a modeling glossary thing that we do. So we can set up a new term called customer, and we can set up synonyms that point client and shopper to customer. Similarly for basket, we decide that actually we like order from the gadgets R Us, we'll keep that, and then we'll align basket to order. That makes sense to us. Again, setting up synonyms. Then gadget and widget, they sound like products to me. Then all we have to do is, with our bags, we just drop them all. We just get rid of all the bags that we had. We're not losing any data because they're just views that sit over the top of our data lake tables. And then we recreate new ones, which are conformed to those new terms. So we end up with something like that. So the underlying data for all of these bags is exactly the same as they were before. It's the same data lake tables, but we've now aligned these to different terminology. Okay, and that is why I call it lazy, because it's too easy to do. We don't have to do any re-engineering. We don't have to build new pipelines. We're just defining a new bag structure. And that's it. So if we're going to have a look at this in terms of what the bags might look like in those two systems, it might look like something like this. And if you want to ask the question, where's all my customer data? We go into our library. Where's all our customer data? All we do is we look for those bags which have that prefix or that string as a field name. So if we've got information metadata tables, we just look at a simple query like this. We just look for anything that has a column name that looks like that. So that'll find us all those tables. And then we're free to join those tables on those keys because we know that they are the same business concept. Same with orders, do exactly the same thing. We're just looking for those fields which have order in. Same kind of thing. So it's really simple. So the metadata is kind of baked into the definitions of the views themselves. Right, so just to kind of summarize, and I thought the best way to do this would be just to kind of walk through with a kind of comparison to Data Vault, because this is where it kind of came from. So business keys. So yes, within Hook, business keys are really important. So it's kind of fundamental. We have to define every business term in our glossary. If it's not there, we can't organize data around it. It's as simple as that. The difference here to Vault is that we generally keep the business key and cast it to a binary field so that we've got the efficiency of joins, but we don't have any issues when we're hashing of the limitations that we have with hashing. Obviously, there's a risk of clashing keys, and obviously there's a performance overhead in actually generating the hashes themselves. So we don't have any of that. The business key collision code is the key set. So this is, whereas BKCC, I think, was introduced into the Data Vault standard relatively recently. Well, I say relatively, I mean in the last few years. Key set in Hook is like it's a first-class citizen, if you like. It's an important aspect in that every single business key has to be qualified with a key set. It's mandatory. We can use it to qualify sources, as I showed you, and also to resolve taxonomies. And I think that there may be other uses. I think that's an interesting area, actually. How we use key sets and how we track them and use them I think, is an area to explore a bit more. Link tables, as you've probably guessed, you don't need them. Everything is collapsed into the bag structures themselves. So we can have multiple keys. We don't have to just have the single key that we have to with satellites, with hub and link satellites. You can have as many, one or more hook keys in there as you choose. Hub tables, we don't really need them. We can physicalize them. You don't have to have a hook table. But if you did, they would be a physical table, and they would be single column. You only need one column. So I wouldn't suggest that you have to put anything in there with, when you loaded it, all that kind of stuff. Essentially, it's like a kind of helper table, if you like, that gives us a superset of all our business keys and used as a kind of a left join structure. So rather than joining between bags, you would generally do a left join onto a hook table. So you don't want to get into outer joins because they obviously don't perform too well. Satellite tables, well, essentially that's what our bag views are. It's exactly the same kind of thing. It's the integration structure of a hook as it is with Data Vault. They can be physicalized to boost performance if we need to. Obviously, if you've got a huge table, it might actually make sense to have a materialized view or actually implement it as a table itself. All our satellite derivatives, so there's obviously different flavors of satellites within Data Vault. We've got we've got effectivity satellites, status tracking satellites, record tracking satellites, multi-active satellites. There's no reason why you can't represent those in Hook in exactly the same way. So yeah, there's nothing different. So if you can think of it in terms of Data Vault, then it should work just as well in Hook. Bridges, don't need them because we've collapsed everything into the bag structure, so it's not required. And then point in time tables, yes, you could do those in Hook, absolutely, but because they're kind of helper tables and you destroy them and recreate them, and then I would suggest that they're not part of the data warehouse. They don't fit the criteria, the Inman criteria. So they would belong in the presentation layer or the consumption layer. Okay, so that's where we're at. Next steps, and this is kind of where I'm kind of reaching out to the community for help. This is very much a work in progress. There aren't any Hook projects in the world, so it's just really a thought experiment at this stage. But I'm looking to generate some discussion around it to see whether this is a viable option in the industry. It needs to be challenged and tested. And I thought, yeah, if I go to the Data Vault community, I'm going to get plenty of challenging and testing. So yeah, please reach out and tell me what you think, good or bad. I'm happy to have that discussion. At some point, we're going to need some kind of automation tool associated with this. I have actually built something, or it's a good prototype. I think that's probably as good as it said. Remember, I said earlier I'm a C# dabbler, so I built something that enables you to, it captures the essence of what's going on. It's got the glossary, we can capture sources, and then we kind of build models around that and do our mappings. And then there's a facility then to generate out DDL scripts based off templates. So we can do that kind of stuff, but I'm sure somebody could do a much better job than I have. And then, yes, obviously looking for projects. Anybody who might consider trying it or running it alongside another project, because I think it's lightweight. I think it's easy to implement. Then yes, please get in touch. I'll be very delighted to have that conversation with you.